Welcome to Learners Academy. This is Mona Bhatia, and today I'm presenting you science lectures of 10th grade. And in this, I'm going to cover diagram based questions. Plus, we'll give you an overall view of how the same topic can be asked in many number of ways. This lecture will cover everything from this topic, and also there are not to be missed questions from this topic as from chapter 1, that is gravitation. Let's continue and let's see what are the questions that can be asked related to this diagram. And board examiners nowadays have they start giving a diagram and then they ask questions related to those diagrams. You should not get scared by seeing the diagram. You should know, if you know the topic well, you'll be able to handle it very nicely. Let's see the questions that can be asked related to this picture particularly. Now the picture is given and they can ask the question like this: observe the given picture showing orbit of a planet around the sun and write 3 laws related to it. Or they can frame the question directly and they can ask you explain Kepler's 3 laws. Or if they don't ask this way, they can even ask show that gravitational force is inversely proportional to the distance of the planet from sun. Or this question can also be asked in a way like, how did Kepler's law help Newton to arrive at the inverse law of gravity? So if you cover this topic well, you will be able to answer all these 4 questions. Plus many objective question based question can be answered if you know this topic very well, because this is one of the favorite questions of examiner. There is no point of missing out this question, and it's too easy also. So now let's go to the next slide where I'm going to ask you certain questions. Now you are given this picture and you have been asked question: observe the given figure showing orbit of a planet around sun and write 3 laws related to it. Or you can be asked directly. So before we start, you should know what is an ellipse, because ellipse is not a circle. It is a regular oval shape with 2 foci, and sun is at one of its foci. This is foci number 1, and the other foci can be here, somewhere here. This is foci 2. So the first law of Kepler states that the orbit of a planet is an ellipse with sun at one of its foci. It's very simple law. Now we'll go to the second law. The second law states that the line joining the planet and the sun sweeps equal areas in equal interval of time. So what does this mean? This means that if this is a planet A, alright, and the line joining the planet A and sun, and if this is period, if this takes 5 minutes from this position to this position, if it takes suppose 5 minutes, alright, and from C to D also it takes 5 minutes. This we are just assuming, alright, and from E to F also it takes only 5 minutes. So the line joining these to the sun, alright, they will sweep an equal area. So this area will be equal to this area, alright, and this will be equal to this. The area of triangle SBA will be equal to area of the triangle SCD, and this will be equal to the area of triangle SEF. Alright, so this was second law. Very simple. Now we'll come to third law. The third law states that the square of its period, what does it say? The square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. So we'll write it like this. Therefore t square is the period of revolution around the sun, and r is the mean distance of a planet from the sun. So t square is directly proportional to the mean distance, cube of the mean distance. So both of these, if we have to remove this sign of proportionality, so we'll get a constant like this, that is t square upon r cube will be a, so this is a constant. Alright, so these are the three laws of Kepler, very very important, not to be missed at all. The question can be asked in any form, so please prepare this question. Let's go to the next question that can be asked based on the same diagram. Now you have to show that gravitational force is inversely proportional to the square of the distance between two objects. Now here we are taking two objects as one planet A and sun. So we are going to take a circular path which is shown in this figure. Alright, this is sun, and the distance between planet A and sun is r. This is the circular path that it is going to take. So the distance covered by this planet will be 2 pi r. So assuming that the planet is moving in a uniform speed, so we have velocity is equal to distance upon time. Alright, so when the distance here will be the distance covered by this planet A, which is 2 pi r divided by t. Alright, now if mass of this planet is m, you remember there is a formula that then the centripetal force exerted by sun on this planet A, which has mass m, is given by the formula F is equal to mv square divided by r, where mass is the m is the mass of the planet, v is the velocity of the planet, and r is the distance of planet from sun. So now we have to take this formula, F is equal to mv square divided by r. Now what we are going to do is we are going to substitute the value of v here. Alright, we have to put this value here. So what do we get? We get F is equal to m, will write as it is. In place of v, we have to write this. Now this will be 2 pi r divided by t, and this will be squared, and this is divided by r. Alright, now we have to solve it further. What do we get? m, 2 square will be 4, pi will be squared, and r will be squared divided by t, which will be squared, and this will be divided by r. Now when there is nothing as a denominator for r, we get 4m pi square r square divided by t multiply by, this is called inverse reciprocation, here this was 1, so we get 1 upon r. So when we solve this further, we get 4m pi square, and this will be t square, right, divide by, now do you remember Kepler's third law? What does Kepler's third law state? It says t square is equal to constant r cube. It says that square of the time taken is directly proportional to the distance between, cube of the distance between two objects. Alright, you remember this law? This is Kepler's third law. So now we will keep this value of t here. This value will be used here. So now putting this value, I get r cube multiply by 1 upon r. So when I solve this further, I get 4m. Now I'm going to break it up for your understanding. Now this is r square. I'm going to write it this way. Alright. Divide by constant. Then r again I'm going to write it this way for your convenience, because I'm going to cancel it in the next step. So when I cancel it in the next step, this r gets cancelled with this r, this r gets cancelled with this r. So what do we get now? 4m pi square divide by k, and this r and this r, they get multiplied. So what do we get? R square. So what we were calculating? We were calculating force. So now you know that this is a constant figure. So that means this force does not depend on this at all. This only depends on r cube, r square. Sorry, I'm so sorry. Um, this will be r square. All right. So hence I'm able to prove that force is inversely proportional to the square of the distance between two objects. Now we'll move on to the next question. Now we will sum up how Kepler's work was used by Newton in postulating his law of gravitation. Alright. So basically, according to Newton's theory of gravity, every object in the universe attracts other object with a definite force, and this force is directly proportional to the product of masses, alright, of these two objects, and is inversely proportional to the square of the distance between them. Now why did Newton assume inverse square dependence on distance? He was helped by Kepler's third law. What does Kepler's third law state? It he where he had proved F is inversely proportional to the square of the distance between two objects. Now if this question is asked for 5 marks, then you will have to if this question is asked for 5 marks, then you have to show the derivation, how we arrived at this. Alright. Now if this question is asked for only 2 or 3 marks, then you have to just add that the centripetal force which is actually the force acting on the planet and is responsible for the circular motion of a planet. This is a circle, and this is sun, and this is the distance, and this is a planet A. And so what is centripetal force? This is this force which helps the planet to move in a circular motion, and this force must be inversely proportional to the square of the distance between planet and the sun. So this centripetal force is inversely dependent on the force. So now Newton, what did he do? Newton identified this centripetal force as the force of gravity, and he postulated inverse square law of gravitation, that is the inverse square dependence. Alright. So that's how Kepler's law helped Newton to arrive at the inverse law of gravity. What is the inverse law of gravity? This. Alright. So that's all about this question. This is how you will prove this statement. Now the second most important diagram of chapter 1, that is gravitation, is this: gravitational forces between two objects. Now I'm going to take up all the questions that are based on this diagram. Let's have a look at that. Now this is also one of the favorite diagrams of examiners. They can ask you a question based on this diagram. So the question that are based on this diagram can be: how will the value of f changes if the distance r is doubled or d changes to 2d? Now what do we understand from the above diagram on state the law? Now the next question can be asked on the same very diagram is: state the mathematical equation for the law. And this question can also be framed if: how will the value of force changes if the mass m₂ changes into 4m²? So these are the questions that you need to look at it in case you want to really attempt all the diagram based question. And if they combine these questions, then this question can be framed for 5 marks, and in case they want to ask you individually, then they can be asked for 2 or 3 marks each. So you prepare this question well, because it is very simple, very easy to score these marks. Now, what do we understand from the above diagram? State the law. Now, you are shown this diagram and they are asking you what do you understand by the above diagram. So, you will say from the given diagram we understand Newton's law of gravitation, and now you have to state the law. So, you will say gravitational force between two bodies in the universe, is directly proportional to the product of the masses, product of the mass of this, and is inversely proportional to the square of the distance between them. So you will write force between them is directly proportional to the product of masses and is inversely proportional to the square of the distance between them. Alright. So now the second question that can be asked, answer will be same. State the mathematical equation for the law. So you will say mathematically the gravitational force of attraction between two objects can be written as F is directly proportional to the product of masses of the two objects m₁ multiplied by m₂, and F is inversely proportional to the square of the distance between the two objects. Okay. Now when we remove the sign of proportionality, we get F is equal to G m₁ multiplied by m₂ divided by d square, where G is the universal gravitational constant. Alright. So this question can be asked for 2 or 3 marks at the most, or this can be clubbed in the question 5 marks question also, along with some other question. Now the question is: how will the value of f changes if the distance r is doubled or d changes to 2d? Here you see this is d. If this d changes to 2d, how will this force change? So let this be force 1 and let this be force 2. Mind you, the masses will remain same throughout. Alright. Now we know that the force, gravitational force between two objects is given by the formula G m₁, product of the masses, and it is inversely proportional to the square of the distance between two. Now this is F1. Okay. Now we are going to take F2 as G will remain same, mass will remain same. The only difference will be this is 2 t, and we have to put the whole square. What is this? This is F2. Now what will happen now if we solve this? G m1 m2, this becomes 4t square. And now you know that this was G m1 m2 divided by d square. This value and this value is same, that is F1. So if we put F1 over here, we get the force 2 will be 1/4 the force. So the force between becomes 1/4 the initial force. The initial force was F1, so the F2 is 1/4 of that. Alright, so this is how you will calculate. Now you are asked question, how will the value of m2 changes if, how will the value of force changes if m2 changes to 4m? That means mass of the second object is now 4 times the initial mass. So provided distance remains the same, m1 remains the same. So definitely force 1 will be different from force 2, because here the mass is 4 times the initial mass of second object. We know the formula, the gravitational force between two objects is given by this m1 m2 divided by d square. And we also know that the gravitational force will be different in case of if the mass is changed into 4 times. Now F2 is equal to G m1. Now m2 is 4m2. Whatever the value was, now it has become 4 times. So we have this. Now if mass 2 is increased to 4m2, we can also write this equation as 4 G m1 m2 divided by the square of the distance between two. You know that the initial value was F1 was G m1 m2 and d square. So this value can be replaced by F1. Alright, this is equal to this. Alright, so we can write F1 over here. So that means F2 is 4 times the F1. Whatever the initial value of F1, F2 will be 4 times the initial force. Alright, now this is the diagram, and you are asked question, what does this diagram show? So you will say that this diagram shows that there are high tides and low tides that occur regularly in the sea. Alright, now the level of sea water at any given location along the seashore increases twice a day. Okay, twice a day. Now high tide and low tide occur at different times and different places. The level of water in the sea changes because of the moon. It has got gravitational force. It attracts the water towards it. Alright, water directly under the moon gets pulled towards the moon, and the level of water there goes up, causing high tide. This becomes high tide here. Alright, now at two places on the earth at 90 degree from the place of high tide, here and here. This place is at 90 degree. See, this is 90 degree and this is 90 degree. So at the two places there will be low tide. Alright. So this is all about this question. Now I hope you understood the concept of gravitation chapter, and if you want to see all the uploaded videos for grade 10, please subscribe the channel and you'll get the latest updates too. And now I have a question which I want to ask you from the topic that I have covered in this session. My question is, in case the two bodies are not spherical, I said not spherical, then in which direction is the force? In which direction is the force directed? Okay. Please send your answers to learnersacademy.classes@gmail.com. Alright. Stay tuned. Thank you guys.